Here we have an exponential equation that we're going to solve. This problem here on the left we can solve as it is, but most people will find it easier to see what to do if we solve the problem over here on the right. You'll notice the problem here on the right is similar to the problem on the left. All we have done is to replace your 2 to the x with an a. Your 2 to the x here, 2 to the negative x, then becomes an a to the negative 1. Now, most people should find it easier to solve this one here. So we're going to just go ahead and remember that we're really going to solve it for a, and then at the end we'll have to plug in our 2 to the x to finish the problem. So over here you have a negative exponent. You're trying to solve it for a. You should realize you don't want to go ahead and have a negative exponent. So we can write it with a negative exponent. You'll notice we also then have a variable in the denominator. You don't want to have your a in the bottom. So multiply everything by an a. Your a times your a is an a squared. Your a times 6 over a, the a's drop. Your 6 times your a, and we get this. Now it's just a normal quadratic equation. So of course you're going to set it equal to 0 to solve it. Then you could try to factor it or use a quadratic formula. In this case, it's not going to go ahead and factor. So we'll use our quadratic formula. Opposite of b plus or minus, put it over 2a times your b squared minus your 4 times your a times your c. Well, when you simplify what's in the root, just typing this into your calculator right here, we then just go ahead and get the square root of 60. Now the square root of 60 is not a nice, neat number. However, when you take the square root, however, it does simplify. You should remember that 60 is a 4 times a 15. So since we have a perfect square inside of your root, you can take the square root of that 4, it comes out front, becomes a 2. The 15 inside of your root we can't do anything with. Now you'll notice that we have an even number in front of your root, an even number in front of your plus or minus, and an even number on the bottom. So you could divide everything by 2. Divide all those green ones by 2, and we get this, or we get this. Now, remember we had said your a before was really 2 to the x. So I'm going to go ahead and plug in my 2 to the x here. And the same thing over here. As we take a look at the problem on the right over here. On the right side, we have 3 minus something that's almost 4. 3 minus something that's almost 4 is negative. So the whole right side is negative. The left side is an exponential function. Remember, anything you get out of an exponential function is positive. So the left side's always positive, the right side's negative. Will positive ever be equal to negative? No. So we have no solution here, since the right side is negative. Well, we'll take a look at the one over here on the left. We'll take a look at this one here. The right side is a 3 plus something that's almost 4, which is a positive. The left side's exponential, it's positive, so we should be able to go ahead and solve that. However, keep in mind that your exponent's in your variable, so we're going to have to use logs. So let's go ahead and apply a log to each side. Then we'll put our exponent in front of our log. We then have x times something, so all we have to do is a little bit of division. So then we divide both sides by log 2. This is your calculator-ready form. Then we go ahead and type that into your calculator to get our decimal approximation. And you might be wondering, do we need to go ahead and check that answer? No, we don't, because we did not start off with an equation with variables after your log. So we have a very similar problem here. We have 10 to the x, 10 to the negative x. So let's go ahead and solve the simpler problem over here. You'll notice they're the same, except I'm replacing each 10 to the x with an a. 10 to an x with my a. So over here, we're going to be trying to solve this for a. Well, let's go ahead and get rid of the 2. So let's multiply both sides by 2. So that way we've eliminated the fraction, but we now have a negative exponent, which is really 1 over a. To get rid of that over a part, let's multiply all three things by a. Multiply this by a, we get this. A times a is a squared. 1 over a times your a is 1. We're trying to solve it for a. You'll notice it's quadratic in the terms of a because you have an a squared and an a to the first, so you're going to want to go ahead and set it equal to 0. Now, in the realm of the quadratic formula, what's in front of your squared term is 1. That's what you plug into your quadratic formula for a. What is your a to the first power multiplied by? A negative 2 and your y, so b is negative 2y. Minus your 4 times what's in front of your squared term times your c value. We go ahead and simplify what's inside of our root. Our root does end up simplifying because you'll notice you have a 4y squared plus a 4. You have a common factor of a 4, so you can pull that 4 out, factor it out, but it's still inside of the root. When you have two things multiplied together in a root, you can take the square root of the first one and then square root of the second one. The square root of that 4 is your 2. Square root of your parentheses stays there. You'll then realize that you have a 2 in front of your root, 2 in the bottom, and what's in front of your plus or minus also has a 2. So divide everything by 2. So this is what we get then for a. But keep in mind, we weren't trying to solve it for a, we were trying to solve it for 10 to the x. So let's go ahead and replace your a with 10 to the x. So it's really 10 to the x equals each one of these. 10 to the x equals the one with the positive root. 10 to the x equals the one with the negative root. Here, take the square root of a y squared plus 1. Y squared plus 1, when you take your square root, would be a little more than y. Y minus a little more than y would be negative. Here it's exponential. Your exponential is always positive. The right side's negative. You'll get no solution. Over here, we'll actually get an answer. Because the square root of your y squared plus 1 is a little bit more than y. Y plus something a little more than y would be positive. You're trying to solve it for x. X is in your exponent, so you're going to have to use logs. In this case, once again, I'll use a common log, apply a common log to each side. Hopefully you remember that log base 10, which is not written here because it's a common log, of 10 to a power undoes each other, and so the whole left side is just x, and so then we have x on one side all by itself. We're not going to have any decimal approximations here because we don't know the value of y. We're just asked to solve it in terms of y.